Okay, it looks like all of our faculty are here. So I'd like to introduce Drs. Stephen Nailway, Wenda Tan, Henry Fu, and Pai Wang. Could each of you, in that order, please introduce yourself, where you got your PhD and what, and the name of your research lab, and any other research areas you want to mention in your specific division. Let's start with Stephen.
So I'm Stephen Nailway. I'm in the DEMS group. I got my PhD at the University of California, San Diego in material science, and I run the Bio-Inspired Science and Engineering Lab. And like I said, I'm in the DEMS group. We do a lot of work on fabrication of materials for different things, nanomaterials, energy materials, and also some research into like ergonomics and how humans interface with mechanical systems.
Great. Wenda? Tan?
Hi, my name is Wenda Tan. I got my PhD degree from mechanical engineering at Purdue University, Indiana in 2014. My lab is the laser-based manufacturing lab. Although the name is that, but actually right now we do more other manufacturing processes other than laser-based ones. And actually we are heavily working on computational fluid dynamics and computational materials for different manufacturing processes. So yeah, so if you have any question or you are interested in my research, please go to my private chat room at 4 o'clock, I guess.
Great. Any other research that you know of your colleagues doing that you want to mention?
For me? No, I think I'm more doing computational fluid mechanics and computational materials and their applications in various advanced manufacturing processes. Yeah, so that's usually how I sell myself.
Okay. All right, Henry?
Hi, I'm Henry Fu. So my PhD is actually in physics from the University of California at Berkeley. I'm here as part of the TFES group, which stands for Thermal, Fluids, and Energy Systems. I'll go over some more of the members of that group in detail if you attend my 4 o'clock session. But briefly, we have kind of 3 different areas in that group. One looks at environmental fluid dynamics of, say, the Earth's atmosphere. Another looks at energy, specifically sustainable energy in terms of energy production as well as efficient energy use. And then a third is focused on micro and nanoscale thermal and fluid sciences. So I'm in the last group. My own research focuses on micro scale fluid dynamics, particularly as applied to the propulsion of microorganisms as well as microrobots. But there are other members in that group who also work on microscale heat transfer, nanoscale heat transfer rather. And again, I can talk about that more if you attend the 4 o'clock session on the TFES group. I think Joy also asked me to just briefly mention the robotics group as well. I mentioned that I work in microrobotics, so I have some connections there. And I don't think we have a faculty member on the panel there from the robotics group. But we also have a robotics center in the that the mechanical engineering department is part of. And we have a number of faculty there who work on controls, medical robotics, autonomous vehicles, prosthetic devices, and so forth. And there are also opportunities to work with people in the robotics center who are in the computer science department as well, who are doing robotics and control work. I believe, and Joy can correct me if I'm wrong, that Tommaso is actually giving one of the 4 o'clock sessions, is that right?
Yeah, the bionic engineer.
Yeah, so he works in the robotics group. He might be somebody, if you're interested in robotics, for you to attend his session. Thanks.
Thank you. All right, let me check my notes. Okay, Stephen and then Wenda, can you give some advice for contacting faculty if they're interested in doing research?
Why don't we let Pai introduce himself first?
Oh, sorry, Miss Pai.
Yeah, I think you forgot me. Name is Pai Wang. I'm very new in the department. I'm the most junior faculty member here, so that's why Joy forgot about me. Anyway, my group is in the division of solid mechanics. So a little bit about solid mechanics division. So we pretty much have half of the faculty members doing biomechanics. So that's mechanics of living things, and the other half doing physical mechanics. So that's mechanics of I guess not that things, but non-living things, right? Physical systems. And also, it's also about half and half in terms of computational and experimental. So everything about mechanics, we have a faculty member for that. So do go through our website and let me know if you are particularly interested in any one of them. I can answer your question later on. And a little bit more specifics about my own group. We are doing waves and architecture materials, so a lot of finite element simulations, a lot of computational methods, and also vibrations and waves are the expertise of our group. So we do a wide range of different problems from aerospace to automobile to micro nano system, everything that shakes or moves or vibrates, that's our expertise. And also, most recently, we also have a lot of projects about machine learning and even quantum computing. So we are not CS computer science, but we use their method to help with solving engineering problems. So yeah, that's about my division and my group. Thank you very much.
Great, thank you. Okay, Stephen, do you want to have any advice for contacting faculty either to do research or getting recommendation letters for their grad school application?
Yeah, I think the biggest thing to keep in mind is that, it helps out a lot if you have some kind of personal connection with a professor. Obviously, everything's kind of run through professors in grad school, both for recommendation letters and for getting into grad school in general. I think, reach out to us via email. If you're going to reach out, I would suggest that, you include a short resume, or CV that really critically includes your GPA. That's something we usually look at right away. Be respectful. I will say, don't send this monster email. Maybe that's just me, but don't send, 6 pages worth of stuff because I'm not going to read it. Send a short email. Ask if you can get into a position where you can talk one-on-one, right? Usually ask if you can get in touch, but I think in general now, see if you can set up a Zoom meeting and talk to a professor, because that's usually the best way to actually start to, really get to know somebody and have a good chance at getting a letter of recommendation or getting into grad school.
Thank you. Let's see. Wenda, did you have any advice?
Yeah, so I think Stephen has said many of the stuff. One thing that I particularly want to remind you is that you want to send specific email. Don't just send the same email to 10 different faculty members, right? So we can see that. We are not stupid guys, so we can actually see that. If you spend a little bit of time trying to understand each professor's research and trying to reframe your resume a little bit, trying to match their research expertise, I think that will be a very good way to grab the professor's attention, right? And I'm also looking at I'm also interested in your transcript, not whether you get an A and B, that's very important, but more importantly, what kind of courses you have taken. Because that kind of, if you don't have any research background, so the transcript kind of tell me what kind of things you can do, whether you can do the things that I want you to do. So that will be just one more additional suggestion, okay?
Great.
If I could throw one more thing in just really, really fast, that Wenda brought up a really great point about sending out bulk emails. Make your email somehow tailored to the professor that you're talking to. It's really obvious when all you did was like look at the title of the lab and tried to act like you knew what was going on. That's very, very obvious, and immediately the email will probably not be responded to. I mean, like you'll just, so try to make sure you actually get on the website of the professor you're interested in, learn just a little bit, take a look at one of their papers, learn a little bit about what they're doing, and try to make it at least semi-relevant to what they're working on.
Great advice, thanks. Henry, do you have any advice for students on being successful in graduate school or ways that faculty can support them as their advisor or mentor?
Yeah, so maybe a couple points. So I think the first thing is if you're going to go to graduate school, try to pick an area of research that you're really motivated by and excited about. A PhD especially is a long time, and if you're not interested in the work yourself, it's going to be a slog. The second thing, and this was alluded to before, is that your interactions with your faculty advisor are going to be really important. And so it's important to pick a group that you kind of fit into in that way. So there are a lot of different learning styles, a lot of different working styles on both sides, both as a student and as a teacher or advisor. And, you know, for some people that just doesn't click and fit well. So when you're looking at programs, looking at research groups, I do encourage you to talk to other people, meaning other students who are currently in that group. And that should hopefully give you an idea of the mentoring style, kind of the work style of the group, what you can expect if you're part of that. And some of those things can be kind of almost as important for your ultimate success as kind of your, you know, your raw technical output, right? So definitely investigate those things. And then in terms of faculty, it's kind of similar just from the other perspective where I think, you know, if you're an advisor, you have to recognize that there are different types of students, different working styles. Some of them are going to be easier for you as a person to work with, depending on your style, and some are not. And so, you know, you have to either learn how to accommodate those or try to make sure that your students understand those expectations.
Thank you. Pi, did you have anything to add on that?
Yeah, I think I will just add 2 points I feel very strongly about. One is that I think the students should aim at developing transferable skills, at least to some extent, because, you know, a lot of research we do is very specialized, but that doesn't mean you will only learn this one thing through graduate school. So doing this research, although that's a very specific topic, but you need to aim at developing your personal skills in multiple fronts, like presentation skills, writing skills, mathematical skills, coding skills, experimental skills, and a lot of them can be transferable in the sense that they can be useful in industry, in national labs, you know, whatever work you take on later. So that's, I think, should be the overall goal of graduate students. And the second of all, I think the second point I think that's really important is that communication with your advisor, with your professor. So, you know, that's really the key. And my personal take on it is that you need to find some alignment with your advisor, with your professor about your research or your work or the things you are trying to learn. So I would say it's hard to find 100% alignment. That's almost impossible, but I think there are a lot of chance you can find reasonably well alignment with your professor so that the communication will be smooth and your research work will also be smooth.